academic stuff. Now for 2 years I'm vice dean for didactics, so this function drives me a little bit crazy. Okay, so at the beginning I'll try to give you an overview of the Warsaw University of Technology as a whole. That's the main building of our university. You can see that's nearly as beautiful as Berekov at your city. And it's located in Warsaw, because we are Warsaw University of Technology, if someone does not know where Warsaw is. So now we are here in St. Petersburg, and Warsaw is in Poland. It's really in the center of Poland. It's a capital. And if we look a little bit closer to this Warsaw, Warszawa, we can see that this is the frame of the picture indicates more or less the area of Warsaw. So the area is slightly smaller than St. Petersburg. We have something like 2 million of inhabitants, and you have something like nearly 5. But the area is not that smaller comparing to your city, and we are located more or less in the center. Those red dots, red spots, indicates different faculties and different facilities of our university. And if we go a little bit closer, this is the main campus. The main building is exactly here. So this beautiful picture is made from this side. And here there are some other faculties. As you can see, we have dormitories slightly far away from the faculty to give the students some free space and free time to have fun. And my faculty, the Faculty of Mechatronics, is located at South. We are so-called Southern Campus, consisting of 5 different faculties, and the mechatronics is a third of the biggest one up there. Okay, these are the sport facilities. So as you can see, the location is slightly diverse, the same as your university. I know that you are not having the main campus only, you have also some other departments spread all over the St. Petersburg. Okay, so let's locate the Warsaw University of Technology at some ranks as well. This is the most well-known ranking, Polish ranking, for the university, higher education schools. And as you cannot see, or you can see, we are the 4th place. So we are not the winners, unless we talk about the technical universities, because we are the first technical university in Warsaw, in Poland, I'm sorry. And the first 3 are the humanistic and economic universities. So we are slightly below the humanism and economy, but still we are the best in Poland as a technical university, the largest, the most renowned. If you wish to read a little bit more about the rank of Polish universities, you can go to this website. It's in English, so you can see the methodology, which is quite difficult to put straightforward, but you can read about it. There are many different factors taken into account to give the overall score of the university. Yet we are winning. I have to add that the Warsaw University of Technology is the best, the leading technical university, and Faculty of Mechatronics. I will make an addition. Faculty of Mechatronics. With the same rank, because this is the rank of universities, we have also the rank of the fields of studies, right? For instance, optics, mechatronics, electrical circuits, and so on, automatics and control. And mechatronics is the leading faculty in mechatronics and automatic control for the whole Polish universities, technical universities. Okay, some numbers about the university to give you a glimpse of how large we are. It's a number of faculties is 19 plus 1. This is actually not a faculty, it's a collegium. So it hasn't got a dean, it has a director. And it has not his own accountancy. The accountancy is the main building. And students, we have 34,000 students, which is quite a lot. I would say, and plus 1,200 PhD students. This counts for stationary, so the full-time and part-time studies. So altogether, we have more than 35,000 students. That's a lot. And especially if you compare this to this number, which is the academic staff. The academic staff is 2,153 people. Altogether, these are professors, doctors, and the MSc. So graduates that are doing a PhD or they are just assistants. Some more fields of studies, 32 different fields of studies. So we cover, in general, we cover most of the fields of technical knowledge, from architecture and up to chemical processes. Various kinds of mechanical, electrical, electronic, chemical, biology, in terms of process, of course. So many geodesy and cartography. So as you can see, we have a lot of different fields of study, and this is something that should maybe be informative for you. It's English-speaking students. It's 1,500 students. Comparing to this number is rather poor, but we are really trying hard to make it better. That's why I'm here. I try to take you with me. Okay, if it comes to international cooperation, we have inter-university agreements, so the agreements between the universities. We have an equal number of 100 this time. We have also the inter-faculty agreements, which is the number of 63, and a bilateral exchange in number of 30. So this shows you how, what kind of movements we are doing around the world, right? If someone of you is interested in the list of all these agreements, they are available at our website. So if you go to the Warsaw University of Technology website, you will find the bilateral agreements. There is a specific English study point in a website, so you can easily search for that information. We also give the full-time studies taught in English for UE and non-UE citizens, so for students from around the world. We have students from Bhutan, from Oman, from Iraq, Iran, from Russia as well. So we have programs given in English in the first cycle. So the Bachelor of Science, we have 8 different programs given in, as far as I'm concerned, in 6 different faculties. And we have 14 MSc programs, so there's higher level programs, the second cycle programs, 14, and they are given in 8 faculties. And we have the international PhD programs in 15, altogether 15 programs. So these are quite some numbers about the university. And because you are opticians, most probably you're interested in optical design, optical science. We call this rather photonics than optics because we go slightly beyond the optical design or optical metrology. So I just want to tell you that not only my faculty, of course my faculty is the leading one, but still there are some other faculties that give some possibility to study optics and or photonics in general. These are physics faculty and electronics and information technology faculties. As you can see here, we have slightly different fields of optical science covered. So we are not competing, we are rather working together. Many different scientific programs we were doing together because of our experiences and this is different various kinds of fields of optics. Okay, and so this is more or less in general about the Warsaw University of Technology. If I would start to talk about the scientific area, we would spend here a day. So let's go slightly focused to Faculty of Mechatronics. So these are 2 pictures of our building. The building was itself made in constructed in 60s of the last century, and not far ago it was slightly renovated. So we get give a thermal shell and the new windows, so it looks quite pretty. No, maybe not the best one, but it's okay. If you want to visit our website, you can have it here. You can also write to our dean's office or to dean. You can also have some information if you're interested. Okay, so let's go to our faculty. I'll try to give you a short overview for the history of our faculty. It's quite interesting. Then about the structure, I'll tell you about the research, because the research is a driving motor for the students, for our teaching programs. So we are trying to be a scientific university, so we are trying to teach students, involving them to our project as well. So I'll put some effort to give you an overview of the research, and at the end I'll tell you a bit about the didactic structure. Now let's start from the history. Come on, all right. Okay, let's start from the right side of the slide. In 1953, we were a section of fine mechanics on mechanical and technological faculty. So at that time, there was not that much faculties, and the huge faculty that was joining mechanical and technological processes had a section of fine mechanics. So we were just like watchmakers, right? And fine mechanics is a watchmaking division. So after 9 years, we become a faculty of fine mechanics, and then we started to build our building, right? And we become an independent faculty. Still, faculty of fine mechanics was rather considered as a watchmakers. So we are designing watches, but additionally to watches, we had an optics, a very strong optical unit. We had a very strong automatic control unit as well. And this, the rising of those disciplines, the optics, the automatic control, and at the same time biomedical engineering in terms of making the devices for biomedical engineering, we become in 1996 Faculty of Mechatronics, because the mechatronics, the word mechatronics, is better describing what we actually are doing at the faculty. So if you compare this number to the year that was 2 years ago, so 12-20, you can actually see that we were celebrating 50th anniversary 2 years ago, and it was a huge celebration, a lot of talks. We had even the talks of the first students that were finishing the section of fine mechanics, so they're still alive. Okay, let's go further. The organization structure, we have a dean. The dean is a lady, so we have feminized the faculty. Professor Golnick, she's a radiologist, so she works in the field of biomedical engineering, and in particular, she's a physician, and she's particularly interested in the radiology. The vice deans for the scientific affairs, that's Professor Cieślicki. Professor Cieślicki is a biomedical engineer as well, though he is working for the automatic control division, and he's mainly interested in the blood flows. So he closely works for the biomedicine, and he closely cooperates with the medical faculties or with the medical universities. Me myself, I'm a photonics engineer, so I'm optician, and my colleague for the devising for student affairs, Xavier Sikiedans, he's a mechanical designer for fine precision mechanics. Okay, and we have the organizational structure of the whole faculty is that we have three large institutes. So the Institute of Automatic Control and Robotics, the Institute of Metrology and Biomedical Engineering, and the Institute of Micromechanics and Photonics. And if we go a little bit closer, you can see that the institutes are gutted, or they're taught into the divisions, the smaller groups that work together at the specific topics, scientific topics. And we have for the Institute of Automatic Control and Robotics, we have division of diagnostic and monitoring processes. This is very important especially for industrial processes, for power plants, for refineries. You have to diagnose the failure of the system and act quickly. So they work in this field. We have a division of actuators for automatic control and robotics. This particular division works mainly right now at the mobile robotics. So they do kind of a drones, you know what's a drone, right? The self-independent vehicles, mobiles, whatever. And the division of automatic control, that one. It's rather a theoretical division, so the people that are thinking about the theory of control. The biggest institute, the Institute of Metrology and Biomedical Engineering, consists of 5 different divisions in which you have medical, industrial electronics, the biomedical engineering, metrology and quality engineering. This one is changing right now because the quality engineering is not in the mainstream at the moment, so they are rather focused in the very precise coded measuring machines metrology. And the division of sensor and measurement systems, these are the electric sensors, especially for gas pipes and so on. And the division of precision electronic products technology. So this is rather technological division. So they are mainly focused on the printing electronics, the flexible printing and electronics, and transparent one as well. So these are most of the, I would say that half of the projects for our university is located at this division right now. So these people are really strong research group. And if it goes to my institute, Institute of Micromechanics and Photonics, for many years we have been divided into 3 divisions. Last year we welcomed the 4th one. So we are divided into the division of photonics engineering. So this is my division. I'm working for that group. This is the second group that holds the largest amount of research projects at the university. So as you can see, the electronics, technology, and photonics are the driving force of the faculty. I may say. And division of design and of precision devices. These were the people who were inventing the faculty. So these are the disciples of watchmakers. And this is the new division, the division of virtual reality techniques. It was divided from this division last year, as I said before. And when I'll talk about the research of the university, of our faculty, I'll give you a short video of this group. And the last one is a division of applied mechanics. So these people are working in the main field of fan analysis and mechanics. Okay, so just to give you some number of our faculty, we have 115 academic teachers, among them 30 full professors, so the professors with a title, and professors with a DSc, so that's a habilitation. I don't know, you should have the same in your system, right? You have a philosophy doctor, and then it's a doctor of science. That's a higher rank. And we have 53 assistant professors, so the people with PhD, and 32 assistants, so the graduate students, and some of them are hired as a PhD. This number does not count PhD students that are not employed for the faculty. We have 55 people of technical staff and something like 20 people of administrative staff, which is a good proportion, because in some university you have something like the equal number of the academic teachers and administrative staff, and that makes no sense. Okay. Let's go to give you some other information. So we have a Polish state authorization in scientific disciplines for the doctoral degree. So we can give a PhD in the following disciplines. That's a machine design and maintenance. The second one is biocybernetics and biomedical engineering, and the third one is automatic control and robotics. So these are connected with each institute. If it goes to the higher degree, the degree of Doctor of Science, so this habilitation, whatever you call this, we have only 2 at the moment, so it's machine design and maintenance and biocybernetics and biomedical engineering, yet we are trying to get the third one, the automatic control and robotics. The papers are already at the governmental unit and we are waiting for the consideration. Okay, so let's go to the research. The main philosophy of our activity is the mechatronic design, so the synergic combination of mechanical, electronic, and IT solutions put together to make a individual mechanism or unit that can read the signs from the environment, which can act to this signs, which can act to this excitation from the environment. And the main topics is design of mechatronic systems and devices, automatic control and diagnostics in particular, the robotics, this is what I've said before, including the mobile robotics. We have the photonics, I'll talk about this in a minute, and the image processing, the biomedical engineering, also diagnostic systems, but for biomedicine, and also we are doing some works on biomechanics, the metrology, sensors and measurement system, micromechanics and nanotechnology, so the MEMS world. We cannot afford for the technological solutions for MEMS, but we are designing them, and with the cooperation with Western companies, we are producing them and then characterize them at our university. So this is a joint cooperation with different institutes or industrial partners. Radiology, so all the CT, right, or MRI measurements and the multimedia techniques. This is quite exotic. But yes, we have a multimedia, so how to use the mechatronic devices to have a nice fun at the disco or at the television. Okay, some other informations. At the moment, we have 4 European grants for the faculty, more than 30 Polish ministerial grants. So altogether, it's like for the, as far as I'm concerned, it's more than 2.5 million euros money for the faculty, only from grants, not from the governmental money. This is the other money. And we are trying strongly cooperate with the industrial partners. Some of the partners listed here are the Orlen is the largest Polish petroleum company. It's like, I don't know, you have, what company you have the largest? It's Lukoil, yeah, it's the PKN Orlen it's the largest in Poland. We have also the PGNiG, so the largest Polish gas company, and some other units of international companies such as Emerson, Styk, the Polish Television Center of Space Research. So because of good recognition of our scientists all over the world, we are participating in editorial boards of many international journals. I would risk saying that each of our academic teacher with a full professor title has at least one, he's a member of at least one journal. So you can see we are quite well recognized. Okay, now we'll go to the scientific research. I'll give you a glimpse of what we are doing. So if it goes to automatic control, I've said that the diagnostic tools is the main stream of our work. And here you can see the really huge system, Diaster, which is an intelligent system for modeling, diagnostic, control, and and control of industrial processes. So this system allows you to be installed at the faculty or the power plant or at the petroleum company. Right? It consists of hundreds of different sensors and control units, and you have one system that drives it all. So you can model kind of industrial process, and you can measure it. You can change the parameters. You can see what is happening. So this is our work. If it goes to photonics, I'll give us more talks about the photonics, because you're most probably interested in photonics, so the optics. So we have various kinds of activities, research activities. First, I'll start from the image processing in terms of fringe pattern analysis. Historically, we were very much involved in interferometry, and interferometry always give the result in the as a fringe pattern. So either it's a holographic pattern, or it's a speckle pattern, or just a normal interferogram. It's a fringe pattern, and we work for many years for different algorithms, for different fringe processing techniques to get the phase from the fringes. Here you have some just examples of the fringes that you can process, and some processed phases. And at the moment, we are mainly involved in the methods such as the wavelet transform, which is kind of a novel method. I don't know if you've heard of the wavelets. Most probably yes. And also empirical multiple decomposition. I risk saying that our group is one of the strongest in the world in the empirical mode decomposition. We have proposed some of the fastest algorithms for processing the fringe patterns. We also use the smoothing splines. That's a new branch. We are just developing it, and the phase shifting techniques. We also work for the interferometry is a coherent measurement. We also use the non-coherent line for measurement. So this is a MONIT. MONIT is a project in which we were developing different sensors to measure the civil construction, because that's quite difficult, and especially if the construction has its years, you don't really know what is happening after, with the construction if it's loaded. You can of course use the point methods, right? So you can see, you can try to measure with the tensometric mechanical sensors what is happening at a single point. But we were thinking of how to develop a method to measure its full field, so how to measure this in a larger area. And we did this with a digital image correlation. So part of our colleagues works with this digital image correlation, and they have a really good result. And they were measuring different roofs in terms of how do they bend after the load, right? Or pipes inside. You can see you can measure the deformation of the pipe under pressure, and you can see the deformation when the flow is inside, right, with a different pressure. So this is very nice technique, since you don't have to actually touch the object. You just put the speckle pattern on it and take pictures, and that's it. So if it comes to the accuracy, it's very comparable to the known mechanical methods of measurement. Okay. This is again interferometry. That was one of the UE projects, the Smarties. That was the development of the specific platform to measure MEMS devices, but on chip, not the MEMS devices that are diced and packaged, but the devices that are on chip. So you just measure it not one by one, but we developed a platform that measures in many channels altogether. For the final device, we did 25 channels, and you can see here this rainbow color is nothing else than not maybe 25 is 21 shapes of 21 flat mirrors of micromechanical mirrors measured at the same time. So the unique solution for that system was that we actually used the micro technology to use to create a matrix of of interferometers. So we did microtechnology for microtechnology measurements. The good solution is that you can switch this if you have different objects. So manufacturer that manufactures different various types of MEMS devices, it can produce the custom measuring wafers. So if he does bridges, he has one measuring wafer. If he does I don't know, IR sensors, then he will take another one. And after alignment, he has a 25-channel raking system. Okay, now we go to holography. I know that at your university holography you have a strong holographic group as well. So we are involved with the holography for more than 20 years, I would say 30 years, and now our main research in holography goes into two directions. One direction is measurements for biological and technical objects, devices, the small ones, and the other one is multimedia, to have 3D displays. This is the first branch. So now we are working on a holographic microscope and tomograph. So what we want to have at the end, we want to have the possibility to measure the volumetric, so 3D distribution of refractive index in cells, the cancer cells, for instance, to investigate whether the cancer cells are present in a biological material. Or we also use this for characterizing the micro optical devices, such as the fibers with the specific tip ends. So that was the cooperation with some Finland company. Okay, as I said, the second branch of digital holography at our university is multimedia. So that was there are two projects. One is already finished, the real 3D. That was the digital holographic video. So the goal was to measure and record on time, and at the same time at a different place, reconstruct hologram to have a full 3D video. And we proposed a system consisting of six capturing units and 6 displaying units that were working together. And at the end, for the final review meeting, it was like that was a cooperation with the Bilkent as one of the partners, the Turkish university. At the Bilkent, they have a registration unit, so they were holographic. They were recording the pencil, right? And the data was sent through the internet, as it's here, and we receive it. And since the review meeting was at our university, the judges, the reviewers, could see actually the reconstruction on time through the internet. So we did it. That was the first reported video stream over internet with a holographic reconstruction. For the reconstruction, we used special light modulators, specifically adjusted at the specific system, let's say. And now we go far more. The project that is running right now is 3D Holo Through, which is the enhancement of holographic content through multimodal capture and holographic display. So now we want not only have a video, but we also want to have a video that can be done not only from the registered holograms, but other optical techniques. So you register the 3D shape or the scene with different techniques as well, and then you make out of this data hologram, and you display this at the other side of the system. So this is now what we are doing. So we want to combine not only holographic, as I said, right, holographic systems, but also, for instance, the fringe pattern or structure light illumination systems. Okay, and now, excuse me. So the other part of our research activity is 3D, 4D data capture for industry, archiving, and medical applications. These are the systems of structure light illumination. And we have a strong group that actually started this from single topography measurements, and now they become their own group, and they created this new division at our institute. And I think the best description of what they've done is in the video that I'm going to play you right now.
Is it possible to model objects' appearance with faithful reproduction of shape, color, and light scattering properties? We present a measurement method which allows precise scan of a chosen object and can turn it into a virtual model in a way that its appearance corresponds rather to its real properties than to the designer's imagination. It is especially important in case of documentation and storage of cultural heritage objects. Our goal is to use the developed method mainly for this kind of objects. Moreover, we can create a copy of the measured object with the use of 3D printing technology. The measurement system consists of a special camera which differs from the traditional digital camera in a way that it captures images in 10 spectral ranges instead of only red, green and blue channels. Another component of the system is a digital projector, which displays a set of fringes essential in shape acquisition. Apart from this, a set of illuminators surrounding the camera allows measuring the amount of light scattered from the surface. First, the shape is being measured. The projector displays a series of rectilinear fringes, which bend on a curved surface of the object. Based on this data, computer can calculate the shape of such a surface as a so-called cloud of points. In the second stage of the measurement, the multispectral camera captures a series of images in different spectral ranges of visible light. It uses optical filters which transmit different parts of the spectrum emitted by photographic flash lamp. The mechanical gears position consecutive filters in front of the camera's sensor. In the last stage of the measurement, the camera takes photos of the object lit by special directional illuminators. This way, the reflectivity of is registered so that we can determine how much light is reflected and scattered in different directions. The cloud of points is a result of the shape measurement procedure. Many clouds acquired from different directions are merged into a single coherent shape model. After that, a triangle mesh can be created. The images captured through spectral filters serve to assess spectral reflectance characteristic of the surface. It comprises of image intensity values for every chosen point on the surface. By knowing the reflectance spectrum of the object's surface and selecting desired light source, we can simulate its appearance in diverse illumination conditions. The color that we see depends not only on the surface properties, but also on the kind of illumination. The surface which scatters light appears as flat, but the one which reflects light comes out glossy. Most of materials in daily experience have a look somewhere between these two cases. The plot shows the way in which angular characteristic of reflectance changes with varying surface appearance. Conducted measurement allows the determination of such a function for every point on the surface. In the end, the texture and gloss parameters need to be mapped onto the triangle mesh, and an animation of the model can be produced with arbitrary illumination conditions. We can compare the final model's look with the source object. We can also print the ready-made model with a 3D printer. It binds a ceramic powder on consecutive layers within the volume. Printed objects need to be cleared from remaining powder with the use of compressed air or with the aid of a brush. Next, the surface is hardened with a resin to achieve final reconstruction.
That's about it. And as you can see, it's not that easy to get the all parameters of or the structure of human body or different mechanical objects, but we did it. And as an output, for instance, this group strongly cooperates with the museums to make a digital copy of the cultural heritage objects. So even did some virtual museums, so that you just make it in a virtual reality the room, right, and you expose the objects, and you can see them as a real objects, not the design in a virtual reality designing units. Okay, let's move forward to we have some other information. If it comes to biomedical engineering, I said that we go to two different branches. It's biomechanics and equipment for rehabilitation. So most recently, our group, the group for our faculty, did a novel bone stabilizer. Right, if you have a hard break of a bone, you sometimes need to put a stabilizer. So there's this specific outer unit that holds your bones together, right? And in principle, it has to help or aid you to cure the broken bone in a relatively short time. And the other branch is the methods and equipment for systems for medical diagnosis and processing of biomedical signals. And in this, we have a strong group that works on ultrasonic techniques. We also have a group that works for detection of ionizing radiation and visualization of internal organs. Here you have some visualization of the brain, right, measured with the CT techniques. And we have also neural networks in diagnostic systems and image processing and image fusion algorithms. This one is very important, especially if you want to merge the data from the CT and MRI, which gives the complementary data. So to merge them, it's not that easy. And the groups at our university works on this topic as well. So if it goes to micromechanics and nanotechnology, I said before that we mainly design MEMS, and then we manufacture this at the Western companies that we are working together with. For instance, Thales from France. We actually do some optical systems to characterize, to monitor the MEMS behavior. This is what I've said before, so I'm not going to go back to that. But I also should mention that we model friction in micro and nanoscale. It works absolutely different than in the large scale. So we have a group that is quite interested in the friction, especially, for instance, in the friction where the AFM tip touches the substrate, right, and try to characterize substrate. So the friction there changes a lot in measurement of a stiffness, for instance, or the mechanical constant of that material. And we have also the cooperation with Japan. One of the PhD students worked with the Kelvin probe force microscopy. It was really novel works in the worldwide scale. Okay, just to end with the scientific research, just introduce you. We have two strategic programs. That's the national programs. The one is CEPT, It's a center for preclinical investigations and technologies. The whole project is worth 130 million USD. We have 10 millions for ourselves, and we are responsible for the Center of Biomedical Technologies and Medical Physics. So we have to, at the end of the project, we have to create a net of open laboratories. And the other one that is under construction right now is a CESAMAT, is a Center of Advanced Material Technologies, and we are the coordinator of the project. The project is worth 120 million USD, and within this project we wish to have a new building. The plans are already done, so I guess the construction will start in next few months. And since our main building, or the Faculty of Mechatronics, is not that, it hasn't got that much capacity, we are the limit of our capacity, it's something like relief, because finally we can move our laboratories, research laboratories somewhere else and give some more space for students. Okay, then we organize as a faculty the international conference, the Mechatronics. The conference is organized every 2 years with the cooperation of Brno University of Technology from Czech, and the last one it was in 2013. Now in Brno. Now we are going to organize the conference at our university in 2015. So you are all very welcome. You can follow this if you type Mechatronics conference. You'll search it in the internet. And the papers are published in a Springer, so they are counted as a JCR in the Web of Science list. So if some of you think of being a scientist, that counts to your curriculum. Okay, we go to the last topic, the structure of studies. So how do we teach people? And as I said before, I think I said before, we conduct teaching at every cycle. So we have a Bologna process. So we have the first cycle studies, second cycle studies, and the third cycle studies. For the first cycle studies, we have a full-time and part-time studies. The full-time lasts for 7 semesters, and then you gain the BSc of engineering, right, the Bachelor of Engineering. And the fields of study are the automatic control and robotics, mechatronics, and biomedical engineering. This biomedical engineering program we share with the Faculty of Electronics and Internet Information Technologies. So this is a shared program with different faculty of ours, of our university. These two are domestic. The part-time studies are given only in the 2 fields, the automatic control and robotics and mechatronics. And we are rather thinking of cancelling them in order to extend the curriculum for English studies, because this is the path that we should follow to make the international to internationalize our studies more than we do up to now. Okay, for the second cycle we have only full time, so they last for 1.5 years, the 3 semesters. And they are the same with the same field of studies as the first cycle. So we have an automatic control, robotics, mechatronics, and biomedical engineering. In this case, biomedical engineering is only domestic, so this is not a shared program anymore. For the third cycle, we have a full-time and a part-time, and in English as well. So you are very welcome to learn at our university for your second or the PhD studies. They last for 4 years. This small plus indicates that not every student defends his PhD in 4 years. The average is something like 6 right now, which is quite embarrassing. But you know, we are trying to study hard, and we give a PhD in 3 different scientific disciplines. I've told about them before, so I'll skip this. And the structure of our studies at the first and the second cycle reflects the diversity of topics and the groups that we have at our university, because we have 10 different specializations over our fields of studies. So if it goes to automatic control and robotics, we have an automatic control robotics. These are the separate specializations. So here it's rather diagnostics, right, and automatic control. So making controlling units. Robotic is rather mobile robotics, and industrial IT solutions. It's a new specialization that prepares students to work as a programmist in industrial for the industrial processes. Mechatronics, we have 7 different specializations. These are the photonics engineering, my specialization, coordinate measuring systems, manufacturing engineering in mechatronics, micromechanics, sensors and measurement systems, multimedia and electronic medical equipment. So they reflect what I said before. They reflect our research, the variety of research we are conducting. Okay, some statistics. So for the regular, the first and second cycle, we have 1,420 students at this year, together all the years in terms of all the students in this academic year. For the part-time studies, we have 250 students. I should mention that we have also the part-time studies over internet, so you don't have to come even on weekend to the university. You do all your lectures through internet, so you just learn and then pass some exams through internet. You have only 2 or 3 times a semester meeting with a laboratory. So this is called okno, which is window in Polish. And a third cycle, we have 70 PhD students, so that gives altogether nearly 2,000 people at the faculty, 2,000 students, which is quite a lot. Some other statistics, that's a candidate per place. So we are having recruitation for automatic control and robotics and mechatronics together. So we first take all the students to the faculty, and then we divide them. We give them an opportunity to choose what they want to do. It's the choice is made after the 2 years of studies. So the first 2 years, it's like common program, right? So they learn the basis of engineering and all. And then they choose their field of study. So we have two person per place, which is not spectacular again, but as for technical university, it's really good. If it goes to architecture, for instance, for technical university, we have 14, but if it goes to this rather not so exclusive directions, like the mechatronics or biomedical engineering, it's only 2 or 3. Yet, if you go to the notes, so the here the FS is a final score. I don't know if you have in your educational system the kind of a maturity exam. Do you pass something like that after the high school? Do you have to pass a set of exams, or really? State exams, yeah. So this is exactly the same thing. So we have the state exams in 2 different levels. It's a basic level and extended level. So if you want to be accepted to our faculty, you have to have 70% of the final score from extended level maths and physics. So it's not that easy to become a student. Okay, and at the end, just to give you a few words on internationalization of our faculty, we have a second cycle program within the Erasmus Mundus in the Master in Optics, Science and Technology. It was run since 2007-8 academic year, and it is still running. So every year we have a recruitation to that program. So the partners of that program are the Institut d'Optique from France, the Imperial College from London, Friedrich Schiller Universiteit from Germany, and Delft Technical University from the Netherlands. That's still the program that you may join if you are interested. And the very fresh program, the program that we have signed with your university, the second cycle double degree program DDP in optical design. So it started since 2012-13. So the first set of students already are working or studying in this program. So you are the partner, and what I wanted to say is that the program is divided into 2 years. So the first year, the students studying here in St. Petersburg, right? So here you have a 2 semester, the curriculum of 2 semesters, and then after those 2 semesters, they come to Warsaw and they study for another 2 semesters in Warsaw. In those 2 semesters, one is quite heavily loaded with the modules, but the other one is the internship connected with diploma work. So the idea is that all the diplomas are made with a cooperation with companies. This is not the diploma from just an academic point of view, but the diplomas that have the application in industry. And I think this will be it. I took you an hour, so now it's your time to ask questions and talk. I thank you so much. Thank you.
Спасибо, да. Вопросы? Вот у нас как раз 5-й курс сидит, которые пошли по программе двойного диплома, о которой в конце говорилось, которые в дальнейшем должны как раз 1 сентября следующего года в вашем надеемся, что все у нас получится. Вопросы какие-то есть у нас? Давайте.
Okay, so you asked about the price, right? Skолько means how much does it cost? What exactly? What the cost of the DDP? You mean? Okay, so at St. Petersburg, the fee is 3,600 euros per year. In Warsaw is 3,000 euros. So this is the cost of the program. You have to additionally count for all the cost of living, right? But we have dormitories, and the cost of living in Warsaw is, I would say, comparable to the one that you have here in St. Petersburg. I was doing some shopping 2 days ago, so I saw the prices. And yeah, we actually, from our side, I may comment that as well. We are doing the following process. So we are searching for the industrial partner in Poland to pay for the fee for students. So it's like we go, for instance, to the big company and tell them that we have this program, right? And if they want to be a sponsor for instance, one student, they can educate him for his purposes. So he can do the master thesis as an application to their company. So this is how we solve sometimes the problem of the fee. Does that satisfy your question?
Адам сказал, что стоимость обучения в Варшавском технологическом университете стоит 3000 евро в год. Здесь она стоит дороже для контрактных студентов.
Это в нашем случае это министерский минимум, который нам спускается, определяется сумма контрактного обучения, и по софтотехнике, по нашему направлению, это максимальная цена, потому что она связана с обязательным привлечением оборудования, да, практически сложного, особенного оборудования, то есть то, что требуется дополнительно, что не требуется, например, для философии, экономики, да, здесь нет. Еще вопросы?
Adam, all of our students are interested. What is a student's life in your university?
Are you interested in students' life?
Yes, they're shy.
Oh, so it's rich. I mean, dormitories never sleep, right? And Warsaw never sleep. The students' club never sleep. So we actually have a club in our faculty. I didn't mention that. I thought that it's dangerous. But we have a metro mechanic. I have to recall the name. We have a club, metro mechanic, at our faculty at the pavements, and they organize concerts. They organize some parties. So our faculty student government at our faculty is a very how would I say this? Towarzyski? Do you understand this word? Towarzyski? So yeah, oh right, thank you. They are very friendly and they like to have fun. So they organize, for instance, the different kind of attractions, such as the laser tag, or you know what's a laser tag, right? So you go and shoot with a laser. That's an optical fun, and they organize kind of meetings with the different bands and so on. So I think that the academic life, the student's life, is not really different from your domestic one. So I guess that all students like to have fun.
How many colleagues and students can take part in your program?
How many students can take part?
From our university.
So at this year we have put a limit into 4 people from each university. So the group has 8 people together. But yeah, I should mention that before. I'm sorry, how dumb I am. Here you have a leaflet of our programs in English. You can also apply to that program. You don't have to go to the DDP if you want to study in Warsaw University of Technology in our faculty. So that's the leaflets for you. You can take that. And this is the first cycle and the second cycle programs. So if there is not enough space for you at the DDP, you can also join different program in English. Okay? Good. What do you mean by how many freedom do I give? I'm not holding them.
What are their responsibilities?
What are the responsibilities of the students in terms of research?
Yes.
Okay, so I've mentioned that at least at our division, so the optical division, we there is every master or undergraduate thesis, the bachelor and the master thesis, is connected with the works we are doing. So in most cases, students are just involved in the scientific work, right? They are doing the part of the work, which is absolutely novel. So this is not like, okay, you have to do a literature search and that's it. You have to work on a specific solution for a specific system, and we are like guiding people, right? So this is your idea. We may give you different ways of solving the problem, and then you choose the solution, and you are working on that solution, right? Unless it's really irreasonable, right? So if you think of something that we cannot afford, then we will definitely put you to the right path. In other cases, you are free to extend your abilities and to extend your solution.
Мы когда посетили Варшавский технологический университет осенью прошлого года, мы на самом деле видели, что все студенты данной кафедры привлечены непосредственно к выполнению проектов научных. И все их, так сказать, НИР, да, в нашем понимании, они непосредственно выполняются согласно проектам кафедры. Да? То есть нету пустых проектов, и в то же время нет студентов, которые ничего не делают. Так? То есть в вечером в лабораториях есть студенты, магистры, аспиранты, и все выполняют какие-то работы. Вот то, что мы видели. And I said that there are a lot of students and PhD students in your labs the whole day, and they do their research, and they work with the teaching staff.
Yeah, we have so much projects that actually students, it's a mutual benefit because you are helping us, right? Because we need a work, hands to work, and we are giving you the experience, right, and ability to do something that is really useful. So this is, as I said, mutual benefit. That's why we always connect the thesis with the research. We don't have time to make additional to put additional work to think of some imaginary problems.
I know that in Europe, if I work on employer, I should have a work visa, and when I study, I should have a student visa. So I heard that we on the graduation we work on real projects in industrial. So is it only academical interest or it's stable?
Okay, I see your point. So you want to earn money while studying. Okay, there is such possibility. This is something we do as well. It's quite easy with the Polish students, right? So, for instance, me myself, I have students that are working for the thesis, right? And at the same time, they work at a different part of the project, and they are paid for that because they're doing the work, just doing the work, and that's easy, right? Because I can pay them, but and they are kind of an employee, right? In terms of international students, that creates a problem because, of course, I could put you to any industrial company as a student and say that you are doing an internship, and that's perfectly fine until you start earning money for that. Because if you earn money, then the immigration office may say that you are not a student, but you are an employee. And I don't know how to solve this at the moment, so I have to search for possible solutions, because there are possible solutions, I guess. At the end, I don't mind if students earning money for work. So,
do students work somewhere else, in restaurants and shops and so on? Do you know about?
I don't know that. No, to be honest, for the first cycle, so the bachelor students, they usually learn. So they don't have time to study, to work. They play and they study, or they play and they study. They have fun and they study. It changes at the second cycle, and it changes dramatically. At the second cycle studies, most of my students, I would say it's 80% of my students, or the students for the whole faculty work. And they don't work in a restaurant, they work for the companies. So if you join, for instance, DDP, right, you are educated, higher educated person, right? You have a higher education because the BSc is a higher education, so you don't have to go to work in the restaurant. You will be admitted to the company. You are an engineer, and most of my students at the second cycle work for the industrial companies. Some of them are not designers, maybe these are the sales engineers or technical staff, yet they work in a field of industry, in the field of in the technical field. So, and that's a problem for me, myself, because then I have a lot of, the students are coming to me and say, I'm sorry, I cannot attend this and this class because I'm working. And I say, then why you are working why you are studying at the full time? Because if I want to fit the program to each of student that works, I wouldn't do that. No, I can't do this. It's impossible. It's just like, yeah, it's impossible. Okay.
Меня просит Александр Александрович перевести. Студенты Варшавского технологического университета не работают в ресторанах, магазинах и так далее. Во время обучения в бакалавриате им приходится много учиться, ну и студенческая жизнь, а во время обучения в магистратуре они все-таки находят себе какую-то временную работу в технической сфере. Младшие инженеры, технический персонал и так далее. То есть все-таки начинают уже строить свою профессиональную карьеру.
I think exactly the same as here. The format of exams. So traditionally, we had either written or oral exams, right? So you either come and write answering the questions, or you talk with the professor to answer the question. Now it changes because of some processes according to Bologna process and all these different demands that we have to give you a specific knowledge, specific abilities, and specific civil. I don't know. I can't even translate this. Competences, civic competences. Thank you. So now we are trying to change our exams into, for instance, kind of a work in a lab, right? So instead of giving just a theory as the answer, you have a problem to solve, right? So, for instance, you are coming to the lab, you have 5 different units, right? 5 different elements, optical elements, and you have to, in specific time, you have to think of a solution or of a particular problem. If there is something missing, you have to say that I would do this, but I need this and this additionally because my way of thinking is like this, and this with this. So this is something like a project-based exam, right? So this is something that we are trying to do. It's a problem. If you have 4 students, that's fine. I can give the 4 different laboratory tables and say, okay, you have an hour to create a interferometric that measures the transparent object with this and this, for instance, accuracy. The problem starts if you have 200 students, right? If you want to make an exam, that would take a week, and no one will pay for that in terms of hours of work. So the problem with the different types of exam is that they want us to change our way of examining people, and at the other side, they don't want to pay for that a single cent of money. Okay. But for the small groups, we can do really funny things.
Здесь тенденция в Европе, в принципе, такая же, как в нашем университете. Делаются акценты на результаты обучения ваши, да, результаты, которые вы достигли при обучении, компетенции. И поэтому аттестация по учебным курсам, предположим, да, по практике, по НИРу и так далее, должна проводиться в виде выполнения каких-то проектных заданий, проблемное обучение и так далее, чтобы вы смогли продемонстрировать свои навыки практической работы. К этому все идет. В малых группах это легче реализовать, дать какое-то задание, когда вы должны выполнить от начала до конца самостоятельно, продемонстрировать. Когда вы делаете какой-то поток, ну, в общем-то, как у нас, 200 человек, то, конечно, это реализовать невозможно. То есть бакалавриат, видимо, остается пока в старой системе, а магистратура уже в новой. Yes, we have the same situation here.
Yeah, we're actually, if I may comment on that slightly, we are thinking of, because I show you the structure of studies, but now we are thinking of absolutely changing this, and we want to start from the second cycle. Right now it's like if we have a recruitment for the second cycle, the student, the bachelor that wants to make his second cycle, he comes and he chooses that he wants to start this discipline, and he wants to study this specialization, right? And then it's like another school, right? So you have a set of modules. You finish the modules, you pass the exams, and all right, that's it. And now we want to make it slightly put some more weight on the outside, on the side of students, some more responsibility for your education. So what we want to do is, instead of choosing the exact specialization, you will choose, first of all, you need to come with an idea what you want to do as a master thesis, and you will search for a tutor, so for the person that will be responsible for you, kind of a supervisor, and you will then choose among the different modules, you will choose your own program so it's like custom based teaching, right? So you will, each student in some of the limiting situation, each student could have a different program of learning. So this is our thoughts, and now we are recalculating this, whether we can afford for that. But because that would be really good, because this is not us that tell you what to do, but this is something that you tell us what you want to which part of knowledge you want to gain, and the tutor will tell you, all right, so this abilities you will get here and here, and this knowledge you will get from here and from here, and all of this will help you to complete your thesis. So that's the idea. We'll see how it works.
Madam, is it just an idea, or it works now?
No. It's an idea, and at the moment we work with a commission of didactics for our faculty to make it real on the paper. I mean, we have to recalculate, because all the courses are combined with the hours for the teachers, right? So we have this type of that each teacher has to do a certain amount of teaching hours every academic year. So we have to do this in a sneaky way, so no one will be hurt, and yet it will work like we want to. So this is an idea that is now processed. So it's not working.
But it's also too expensive, I think, to have a tutor for each student.
From first calculations, it seems that each tutor will have 2 to 3 students. It's not that much. I mean, we usually have 2 to 3 bachelor thesis or master thesis under supervision. So this is not really difficult for us to handle. We actually have a glimpse of that program. It's like, I have to recall, individual studies program. The best students always can come to some of the scientific stuff and tell that I want you to be my supervisor, and I want to have an individual program. and then together with the dean and the guy responsible for the program for the whole specialization, they try to figure out this individual program. So it works, but now occasionally for just a few students per year, and now in this year we have 4 of that students, but we want to do this for 200 of that students, which is slightly different scale adventure.
Okay. Идея состоит в том, что и в нашем университете также есть такая идея о том, что каждый студент должен иметь индивидуальную траекторию обучения. Да? Он приходит к своему научному руководителю, говорит: я хочу в дальнейшем заниматься каким-то вопросом оптотехники, предположим, да? И научный руководитель ему рекомендует, какие курсы, в каком объеме взять, в какой очередности и так далее. Да? И он его постоянно координирует, осуществляет мониторинг и так далее. Вот. Надо говорить, что сейчас несколько студентов уже запущены на такой проект. Вот. В нашем университете тоже планируется когда-то на такой перейти. Наверное, уже вы этого не застанете. Может быть, уже в магистратуре.
В смысле, в магистратуре. И здесь
тестовом режиме.
Ярким примером является, например, научно-исследовательская практика в САУ. Вот у нас 2 магистранта буквально в апреле, полный месяц, были на Северном Кавказе, 6-метровый телескоп, проходили там практику. Понятно, что она не вписывается в стандартную программу обучения. И это как раз вот то самое индивидуальная траектория обучения, когда человек, специализируясь на определенных задачах оптотехники, да, получает не стандартное обучение, а идет по какой-то своей траектории, по каким-то своим точкам, которые ему интересны. И здесь могут быть, конечно же, шаги вправо и влево. Для нас это тоже новый момент, и мы потихоньку начинаем, конечно, с магистратуры легче, когда это не поток в 100 человек, да, а именно индивидуальное обучение.
We try to make the same idea to realize it, and this spring we forward to students of fifth to the astrophysical laboratory. It located in Caucasus region in the south of Russia, and they work 1 month, yes, 4 months. 1 month, and prepare the research project, and it's some steps to the individual path of education for us. Also, we in the autumn we will forward to students to the Old Biology College Israel to the mobility program. Yes, and it is also some steps to the individual path of education.
То есть на сегодняшний день глобализация, да, и вот эти изменения, они касаются и образовательного процесса. Естественно, мы не можем оставаться здесь вне вот этих общих тенденций. Можно вспомнить и Болонский процесс, который объединяет европейское образование. Здесь как раз это все в одном направлении идет. Может быть, да, не все из вас коснутся этого, но наиболее активные, тем, кому интересно, они как раз попадут через вот эти новые изменения, смогут получить и новые знания, и новые компетенции, и, соответственно, расширить свои возможности в дальнейшем уже в карьерном росте. Ну, вот это для активных, пожалуйста.
Alexei says if you're active and interested in professional achievements, you can try and participate in different programs at our department and university in common.
Thank you. Thank you. It was my pleasure. At the end, I wish you good choices at your lifetime. So all the best. Take care.